In today's interview, we dive into David's take on the rapidly evolving solar revolution and his plans to bring environmentally sustainable, energy-positive homes to the mainstream.
Okay, so today we've got David Morgan from Iron Matrix on. One of the key reasons I wanted to have him on was because I recently wrote an article, a blog post that went into detail about the costs and where we see energy going, and how we think we're at the point now where there's going to be some really rapid changes in the energy system over the next few years, and it's going to make a huge impact on anyone who's investing, and particularly with the size of the companies involved. We've already seen a bunch of coal companies all go bankrupt in the US over the last few years. We think there could be a very similar profile over the next few years for other companies in the energy space. So what we wanted to do is get David on, who's working in a startup company in this very space, and talk to him about some of the latest technologies and some of the costs and what he's seeing at the coalface, so to speak, of the solar industry.
After the interview, we then look into some of the wider investment implications that these themes can impact how we invest money every day here at Nucleus Wealth. So join Nucleus Wealth's Head of Investments, Damien Klassen, and myself, Tim Fuller, as we learn more about eco-friendly innovation that promises to move Australian housing manufacturing into the next generation. I hope you enjoy. Today on the show, we have founder and CEO of an exciting new eco-friendly housing startup, Iron Matrix. David Morgan, welcome to Nucleus Investment Insights.
Gentlemen, thank you very much for the invitation.
Wonderful. So look, I thought we just might begin, if you wouldn't mind, just sharing a little bit of background about yourself and your drive to kick off and run with this Iron Matrix new start.
So basically I've got a background in engineering and commerce from UWA. I actually joined the oil and gas industry. I worked for Woodside for 9 years and then Chevron internationally for 9 years. My background is very much in energy. I worked on major capital projects, so I really pulled together the technical and commercial justifications for these mega projects, and then ended up doing that all over the world. Had a number of insights by virtue of the fact that I was bringing together really what was thermodynamics and economics. And through that insight, I was quite successful. I was one of the youngest major capital project managers when I was 35 years old. So I had the insights, though, were actually telling me that the future of energy production, or at least the growth in energy production, was going to be challenged coming from the oil and gas industry. And that was actually enough to motivate me to take a couple of years. I took initially 2 years unpaid leave and started a prototype of a construction system that ultimately turned into Iron Matrix. So in a nutshell, we basically create a structural steel system that can be entirely clad in solar panels. And what that means is that we can create buildings at a cost that's actually lower than traditional buildings, but basically they generate energy for free.
Excellent. And so I guess from that perspective, like the solar panels you're putting, say, on the side of the house and factors like that, they're not particularly efficient compared to what you could do, but it's cheaper than putting cladding there. So
yeah, absolutely.
Whatever energy you're getting.
The prices of solar panels have got to a point now where you can get a solar panel on a dollars per square metre basis. They're cheaper by the time they're installed than structural plywood. The issue only becomes, can you actually put a tempered piece of glass on the outside of a structure? Because structural plywood actually offers a building some structural integrity. So we designed the steel structure specifically to be clad in a piece of glass that you can't cut and you can't stress.
Right. And insulation-wise, what's the? Do you need to add extra insulation, or how does that work?
Look, all construction, good construction method means you're going to try and avoid the loss of energy in a building. For our buildings, we put a layer of insulation. There's a gap. There's a solar panel on the outside, an air gap that allows convection, and then we put insulation actually within the frame of the steel, and then you've got your internal cladding for a building. So we put in insulation that gives us about an R4.0. But interestingly, on our prototype.
Sorry, just to confirm for those not in the construction industry, what an R4.0 means?
It basically relates to the amount of energy that can pass through a surface. It's a measure of the conductivity of a material. And what you're basically trying to do is avoid temperature differences moving from one side of the other of your insulation. So when it's cold outside, you want to keep your heat inside. And the 4.0 is basically a measure of how well that insulation works.
Yeah, and so a typical house sort of built 10, 15 years ago in Sydney or Melbourne would or Perth would have what type of rating?
Yeah, you'd have 3 or 4 insulation. If you've got 6 stars, you're going to be moving to at least an R3.0, R4.0.
Yeah.
Interestingly, within our prototype, and when I take people out there, it's a bit of a paradigm shift. So they ask, it's a very natural question, what do you do for insulation? But ultimately, we're generating the electricity from those panels at an incrementally zero cost. So I tell people we will be running our air conditioner here 365 days a year, 24 hours a day, and we will not care. So it's kind of a difference to what people are used to, because when people previously always thought about sustainable construction, it was all about that conservation of energy loss. But where you've got a building that's actually generating its own electricity, it becomes a different equation. And insulation has a marginal utility on return. So you can keep investing in insulation, but the amount of money you put in for an incremental improvement in insulation actually just keeps going up and up and up.
Right. So, okay, so that's a bit of background about your company. We might jump into the bigger sort of macro picture and where I was hoping to get some answers from you. Now, we first touched base, I guess, based on an article I'd written. The basis of that was around this whole idea that solar plus batteries are the killer app of the energy world. In that, if once you can get solar power feeding into batteries, that then solves the intermittency problems. And if you can get that at a low enough cost, then that sort of trumps other forms, because that solar plus batteries have both been decreasing by sort of 20% per annum in costs over the last sort of 10, 15 years. And actually solar, if you go back even further, has been dropping quite dramatically in terms of being pretty much an afterthought 30, 40 years ago to now sort of one of the cheapest methods possible of generating energy. And so the idea from me is that it's extremely scalable at the right price, but we're not quite there yet. And the prices have been falling so fast, though, that we are actually almost there. And if you sort of extract forward and said, well, if we got 20% per annum cost savings again for the next sort of 4 or 5 years, then solar starts to not only sort of cut out new coal-fired power plants and new other forms of energy, but you actually get to the stage where you'll start getting rid of some of your existing forms, because the cost will be so low that just the fuel cost of running a coal-fired power plant or a gas power plant will be sort of at parity with what you'll be able to generate solar for.
Yes.
And so that's my thesis, yeah. And I wanted to sort of hit up David now on some of his thoughts, particularly on some of, I guess, what you've been seeing on the cost front in the on the solar side, for example, at the moment.
Yes, absolutely. So I think your insight was extremely shrewd, and it's one that a lot of people, I feel, are struggling to come to grips with right now. Exactly as you said, the prices of solar panels has dropped precipitously since, the 1990s. There was a time where people thought that once solar got below $1 per watt, that it was game over for the fossil fuel industry. That didn't happen, and fundamentally it came down to the reason that you just mentioned, that you need to not only generate but also store, so that you can dispatch that energy when it's actually demanded. The key element there then is the storage, and it's the storage that's basically been the Achilles heel of renewable energy generation for all of time. And what we're seeing now is that, yes, batteries seem to be the alternative that will be the technology that ultimately provides you a kilowatt hour within your house at a price that is competitive, and one day probably more so with current utilities.
Yes. And so, okay, so we're seeing that from both the batteries and the solar side. I guess getting to the technology, it seems to me that in both batteries and solar, we might start with solar first. There's an extremely diverse set of technologies out there,
Yep.
and I guess what I'm most interested on the solar front is. I guess the most interesting technology that you're putting in today, and then versus some of the sort of future where you can see that the industry going at the moment. So
Yeah.
today, what are you using?
So we're quite mature. We're using a traditional solid silicon solar panel, an amorphous solar panel. These have been available for a number of years. Our philosophy was to ensure that we were benefiting from the lowest cost material because it was being used as a cladding material. And that happens to be a solar panel that's in a standard industry form factor. And those are produced in the factories in China for dollars per panel right now, and turned out at millions and millions of panels a month. So that was the intention. That's a very mature technology. But if you look at the cost of delivered kilowatt hours per dollar, that's basically the best that you can actually get right now. That's not to say it won't change, but I don't actually see a technology that's going to reasonably compete with a silicon solar panel at this point in time.
Yeah. So some of the thin solar, I guess it's probably not quite the same application, but there was a lot of I guess a lot of hype a few years ago about the potential for that to be able to sort of paint it onto structures and generate very low wattages, but do it so cheaply that it makes sense.
Yeah, absolutely. So it's super interesting. I think perovskite solar panels also have, they're flexible as well, so they can be put onto a structure with a profile. Very interesting. I think the technology is already at a point where you've actually got very reasonable efficiency, so around 21, 22%. The cost is also competitive. So if I was to put one of those solar panels out in the sun today, I can generate electricity at 30 cents per watt. The biggest issue that they have is the degradation. So the actual chemical the chemical composition and the lattice that's actually within there degrades to the point where unfortunately it doesn't have a life at this stage beyond 1 or 2 years. So that's the struggle that technology has right now. When you look at the full life cycle economics of all of the elements of what we're trying to do to displace fossil fuels, you have to look at the total life cycle cost. And at this stage, those panels don't really look like, as type of solar doesn't look like it's going to really be competitive in the near future anyway.
Right, and so that 30 cents a watt is based on that short lifetime though.
Yeah, so if you can, and it's per watt, not per kilowatt hour, right? And the kilowatt hour is a total energy generated capability, where a watt is how much power you're getting at any 1 minute or any 1 second. So yeah, you can get the power for one day, but really you need to have that same power continuously generated for 10, 15, 20 years.
Yes. And on the solar panel side, I think most of these come with, 20-year warranties now?
Yeah, 10
right?
to 25.
Yeah, so they'll come with that warranty. The Australian standards say that it's got to be able to produce 80% of its original capacity after 15 years. And all of the panels manufacturers don't really have a major problem doing that. And in fact, as you point out, they're actually offering warranties that are beyond that.
Yeah. And so, and I guess, are we seeing improvement on that front?
Yeah, look, it's incremental. Based on the curve, we're getting close to the asymptote at the bottom. It's not going below zero cost.
Yes.
But yes, the technology is incrementally improving, so we're getting more watts per square meter, and the panel costs are going down. It's like 3 or 4% per year. But Damien, as you've pointed out, if you look at the contribution to the final bottom line, the solar makes a 1 or 2 cent contribution to that, whereas batteries at the moment are in the 15, 20 cent. So it's actually the batteries that have the far greater potential to make a big difference in this equation.
Yeah, certainly. So, okay, so just before we get off the technology of the solar panels, though, so I guess what I'm thinking is you've got a number of things working in your favour though. So as you said, you've got the efficiency side where the technology is improving in terms of, I guess they're adding extra layers and other things to so you're getting an efficiency gain on that front. You're getting a density gain by the sounds of it as well, and so you're getting packing more into smaller spaces. You're getting an economies of scale, which I think is actually one of the biggest changes. I think, if I'm right, in terms of just saying you're producing 2 million panels rather than 1 million panels, just means that you can do it at a much lower cost.
Yep.
And then, on the installation side, I guess that's the part where it feels as if that's got the least opportunity for prices to fall, given there's a human usually screwing it in, or am I wrong? And are we seeing more efficiency in terms of the installation side as well?
Oh, look, I think people are getting better and there's more competition within that market. Look, over I think 30 or 40% of the cost of a rooftop solar installation is about the labour and travel and permitting and things like that. That was also the opportunity that we saw. We've got a panel system that you can install from the inside of the building and access the roof. So that was the opportunity that we're also trying to capitalise on with our technology. So we don't put on a roof and then ask someone to go up there. Those people need to be trained for protection, need to make sure it's safe to do so. That's expensive, right? Whereas you can put a panel on your roof from the inside of a structure where you're not exposing people. That's a lot safer and a lot less expensive. But ultimately, training people, making sure they've got the appropriate OH&S, that's still going to be a minimal cost that you can't get away from when it comes to installing on an existing roof.
Yeah, sure.
Dave, just a quick one, actually. I have a feeling that your answer might lead into our next direction in batteries. But I've got solar on our roof at home, and something that we came up against was that there's a grid connection limit that you can't sort of go above without sort of exploring three-phase. How does that relate into, I guess, your plans with what you're looking to build out? So, I think we were limited to 20 or 24 panels, and I think looking at some of your documentation, you can get out to sort of 40 and 50 panels, with plenty of walls. Just some comment on that.
Yeah, so the reason is that the utility companies don't want too many people generating that much electricity in the middle of the day.
Right.
So there's a limit on what you can put into the grid, but the key element there is that you're interacting with the grid. And by doing so, you have to basically follow the rules of the grid. You need to make sure you're putting those electrons in at the right frequency and voltage. So there's a lot of rules around that. And yes, ultimately, these utility companies realize that you've got to actually use the electricity that goes into the grid. It's an instantaneous thing because there's no storage within the grid itself. So they recognize that everyone can't be putting in, 30, 40 kilowatt hours a day from their house or more than 5,000 watts at a time. So they limited basically that upper limit. And the incentives at the time were also designed to make sure that it didn't run away, I think, as well.
Okay.
And so I guess that this to me feels like one of the issues where if you're building a grid from scratch right today, that wouldn't be an issue because you just design it for it. But it sounds to me like another problem that batteries will solve once you sort of go, well, Tim, you can still have your 40 panels if you want, but we just need to sit a battery in between it so that we're capturing the excess that you can't stick out onto the grid, and then we'll let the rest flow through.
Yeah, absolutely. So that is the key inflection point at which when batteries become cheap enough such that you can store all of the energy that you're generating for your own use, and then you're not interacting with the grid unless you see some reason to arbitrage what you've generated back into the grid at some point. When the batteries get cheap enough, and I will explain in a little bit, I actually think they're there today. This is going to create a massive inflection point in the way that we generate and distribute energy, especially in any new areas, new development, and it's going to unlock the ability to actually live anywhere because you're not going to be tied to needing to be connected to the grid.
Mm. So okay, so let's go to the technology side and the batteries then. So same question, but flipped around to sort of say, well, what are the current battery technologies you're using? And again, and this is for, I guess I need to be specific as well, isn't it? This is for residential, which is quite different to utility scale, and even at the utility scale, there's sort of that difference between transmission batteries and ones sort of storing power and sort of ones that are there to flatten things out.
Yeah, you'd think that there would be a dramatic difference in the chemistry and the modularity of the elements, but there actually isn't. If you look at a Tesla Powerwall, which is the sort of thing that you might put in your house in order to allow you to arbitrage those daily costs between peak and off-peak, they actually have the same lithium-ion 18650 battery that you find in a Tesla vehicle. And those batteries are actually, they're not dissimilar size to a AA battery that you'll have in a lot of appliances. That's actually extremely modular. So you can break those elements up and increase and decrease the size of those. Excellent response time. So yeah, they're fantastic to actually provide that rapid response to the grid. They don't have inertia, but the electronics and the computing behind them actually allows that to basically provide a very, very quick amount of energy into the grid to manage that demand response.
And so what are the battery technologies? So you're basically looking at lithium as being the winner at the moment.
Lithium, and it's I'm agnostic. I will take whatever battery provides the lowest cost dollars per kilowatt hour. The technology that's available right now definitely suggests that is a lithium chemistry. There's a number of different types of lithium chemistry, and it depends on what it is that you're using the battery for. Going back to the Tesla battery again, this is a battery that they wanted to be able to produce at economies of scale for vehicles. And Elon Musk has a desire to be able to send a vehicle from 0 to 100 kilometers an hour in less than 2 seconds. That takes a lot of current. So these 18650 lithium-ion cobalt batteries allow you to draw a significant amount of current that will give you the power to accelerate a car that fast. Your house doesn't really need to go from 0 to 100 in under 2 seconds.
Well, so. And I'm guessing most cars as well don't actually really need to go from 0 to 100 less than 2 seconds.
You want it to, whether it does are two different things, yeah?
Yeah, exactly, yeah. Especially when you've got teenage kids learning to drive. I'm sort of, yes, I'd like to have a safety setting for those ones to bring it back to, yes.
Indeed. So yeah, the chemistry that we use is actually a lithium iron phosphate battery. It's a little bit more expensive if you look on in terms of capacity, dollars per kilowatt hour. It's more expensive than the lithium cobalt, the lithium ion, ION battery. But what you find with these lithium iron phosphate batteries is they actually have a higher cycle life. And that's actually the key element that will ultimately differentiate battery technology for housing applications. So a lithium cobalt, the Tesla type battery, it has around 500 to 1,000 and possibly up to 1,500 cycles. And that gives you a delivered kilowatt hour of around 30 cents. And 30 cents is approximately, what we would pay for electricity out of the plug in your home. So that's marginal, right? Well, it's not marginal. You can't afford necessarily to put that sort of battery in order to generate and hope to be cheaper than the utility company. The lithium iron phosphate battery, however, has got a 3,000 to 4,000 cycle life. And when you look at delivering its capacity over that time, which is, near 9-10 years, you're looking at a 10 to 15 cent delivered dollars per kilowatt hour. That is extremely interesting because that is half the price that you pay for electricity out of the grid.
Okay. Absolutely. And so that's that relative to hydro as well. So that sounds like as if hydro, which was basically you pump the water back uphill and then so it gets to come back down again. That's sort of and we had our Prime Minister suggesting that was might be a good solution to a lot of these problems? That seems as if these prices have passed it by.
Well, the pumped hydro is excellent in terms of the amount of energy and the delivered, again, dollars per kilowatt hour. It's excellent. The problem with pumped hydro is that you have to only put it where it's geographically possible. So you need a head difference between where you're going to store the water and then where it's going to run down to, and you've got to put your hydroelectric in between in order to generate the electricity. That typically is going to be outside of a city somewhere, which means then you actually have to put the transmission lines in and send it all the way to the people who are actually demanding it, or the customers in the city and industrial users. So the actual storage technology is fantastic. It makes an awful lot of sense. It's actually the distribution that I think is always going to be the thing that you're not going to be able to get away from, and ultimately batteries are going to pass it by.
Okay, and I mean, I know there's a bunch of people working on a whole bunch of whether it be I don't know, flywheels or airflow batteries and all these other types of ones. I guess, are there any of those other technologies you think we should be keeping an eye on?
Oh, look, I think I'm a mechanical engineer by background, so I would love to say a flywheel or a mechanical solution is the key, but it's just never going to be the case.
Yeah.
What you want to focus on is actually chemistry, so battery chemistry. No moving parts other than electrons. Anything that's got mechanical elements to it, ultimately over the sort of periods that we're talking about, maintenance issues, wearing issues, downtime issues, these things are the things that actually kill renewable technologies that ultimately have a mechanical element to it. Solar panels are solid state. A battery is effectively solid state as well. These things have extremely good reliability, which then gives you that capability to deliver the cheapest kilowatt hours over a 10, 15, 20-year period.
Just a quick one, actually. Vanadium. There's those the red flow, redux flow. Have you had much of a look at those?
Very little. Again, I'm agnostic to the type of battery, just how cheap it is. The benefit of those flow type batteries are that you can immediately replace the electrolyte. So a battery takes time to recharge. Whereas a flow battery, if you wanted to, you can remove the spent electrolyte and basically put in a new one and fill it up like you would fill up a car. So there are benefits there if you need to do that quickly. But my belief is actually that we will move away from the need to have very fast refueling, and even the mentality around that, when people basically plug their cars and their houses into anything and everything that's going to be everywhere around you. You're going to forget about fast refueling when your car just charges up overnight in your garage by itself without you even having to think about having to recharge it.
Okay, sure. I might have to sell my vanadium penny stocks then. Thanks for that. But anyway.
It is. Look, if you want to look at investment opportunities, you look at the elements within the most interesting battery technologies. I was saying to someone the other day, you might want to have a look at phosphate, which means getting into seagull guano.
Yes. That's and you've got the competition there as people. That's a key element into some fertilizer as well. Yes. But I think as well some of the phosphate, just in terms of economics, from this coming back a few years from my days as a resources analyst. But there, I think for some of those as well, there's some really big mines in that haven't been built yet, and so what you find is. If some of these big mines don't get built, the economics actually work really well for some of the small miners. But then all of a sudden, if one of these big guys goes, oh, you know what, here's my my new mine that's going to be 15% of world demand, all of a sudden all the small guys get wiped out. And
I think you're seeing the same thing with lithium, right? It was a hot topic. We're talking about making gigafactories. A lot of people jumped into it, and then prices dropped. Not a bad thing unless you're actually owning stocks. It's a fantastic thing if you're interested in selling battery technology.
Yeah, because I think I sort of think of lithium a bit like iron ore in a way, in that you've got some, you can have some small mines that can be very profitable when the prices spike, but in the end, the bulk of it comes from the really, really big mines that are just huge industrial processes to make things really, really cheap to get to process it.
Yeah, no, I think Chile, Argentina, Australia are best placed for those large mines. I think they mine a bit in China as well out of some sort of brine.
Mm.
Okay.
Now we spoke a little bit about the transmission of energy,
Mhm.
because I know China's quite big in terms of trying to get, well, not only it's sort of trying to move a lot of its coal-fired power plants from the east, where all the cities are, and off to the west, where all the coal is,
Yep.
but also looking to put a lot of solar and wind out there, and then run ultra high frequency lines back to the rest of China,
Yeah, high
which.
voltage DC, I think, is the technology that they're looking into.
Yeah, and so the question for me though is, if the solar power, if you get dense enough that you can get enough electricity into it, then it seems like you wouldn't actually need that. So
Yeah,
I think one of
absolutely.
the common complaints for renewable people is, oh, you have to cover the entire Australia in solar panels just to get enough energy for everyone. It's like, well,
Mm.
based on your 1970s technology, yes, that's right,
Yeah,
but
that's not the
um,
case.
they're getting denser and denser. And so I guess your thoughts are on. So I mean, obviously, a house you can do. People can already service a house from their own panels.
Yep.
How big of an apartment block do you think? If you got to say a 6 or a 10 or an eight apartment block, is that got enough space now to generate its own electricity? Or
Gosh, no. So I mean, it depends on how many people obviously are underneath. So it's a
yeah,
function of footprint. Footprint is what dictates how much radiance you're getting from the sun. Roughly speaking, I would say you need like 30 to 40 square meters a person. That would be more than enough to generate sufficient electricity for your household use, and you could also plug in your electric car and do a daily commute with that sort of kilowatt hours. So in the 20 to 30 kilowatt hour range, and
yeah,
yeah, that would take about for what we do, our technology, because we cover our entire roof with solar panels, because we make the roof out of solar panels. Yeah, you're looking about like a 36 square meter structure for a person to have 20 to 30 kilowatt hours per day.
right, okay. And how fast is that coming down, do you think?
The price, so again, it's a function of
Oh,
the
sorry. I guess I'm
cost of
talking the
solar.
density. On the density side, are we talking
Yeah,
like eking out 1 or 2% a year?
yeah, no, it's not going to change dramatically.
Yeah.
I bought solar panels 3 or 4 years ago that was 320 watts, and we recently bought some that were 360 watts. So
Mm.
there's probably 3 or 4% density there. It's
Mm.
not going to make a massive difference in the short term.
Yeah. Okay. So we're still going to need pretty decent, yeah, distance. I guess when you start packing cities full of and want to start running cities from this, you still need to have these high density lines running from.
Yeah, it's questionable. So it depends, and I'm of the philosophy that our cities were actually born out of our need to access energy as cheap as possible, and the cheapest energy delivery and generation for the last 100 years has been thermal power plants or fossil fuel powered power plants. Those generators benefit from thermal economies of scale. Effectively, the bigger the generator, the more efficient it is. What that means is that you have centralized power generation. Then what happens is you have to then distribute that power generation, and we do that through an alternating current in order to get it to all of the consumers at the best efficiency as well. Where you're actually able to generate energy in any location because you have solar panels, all of a sudden the need to transmit it long distances actually goes away. And what that means is that you can then actually move out of the city and live somewhere that would actually be at a reasonable price, because you're not paying for the cost of transmitting electricity from a centralized power station to wherever it is you're living.
Mm. So, and I guess so. It might have been a confusing one. I sort of sent these. I guess I sort of see there's three different elements to this. One is you sort of completely self generating. So everyone's just like, I create my own power and I use myself and I don't even need a grid. And the second bit is, well, I need a local grid because I might run out, or I might have a big need for power over a short period of time, and I want to draw from my neighbours, and then they'll have a big need on another day, and I'll give it back. And so I sort of need a couple of thousand people, I suppose, to balance out those types of factors. And then there's the last stage where we are today, which is, look, we need big grids because we're pushing everyone this out to everyone, and we need economies of scale.
Yeah, so I think it will be a bit of everything there, right? And it'll as it transitions, it will move from where we are today with the big grid and everyone gets their power from it, to what you're saying, where there is the potential to transmit that electricity between users locally. I think that will be another interim step. And then finally, it will be cheaper to generate all of your own electricity and store it. You might end up selling it to your neighbour. I actually think that the grid will supply the ability to provide backup generation when you've used your battery, or that the sun stopped shining or the wind stopped blowing around where you are, and you'll use that to actually top up your batteries, bearing in mind as well that you'll also most probably at that point in time have a battery in your car as well, and so will your neighbour, and it will get to a point where the battery and the amount of generation is 2 or 3 times what you would use on an average day, at which point that whole grid reliance kind of will naturally disappear.
Yeah, okay. And so and so a lot of that seems to come back to the battery cost, as you said, the storage of it in terms of what it's taking to actually store the energy.
Yes, and
So,
the key thing I'll just mention that with the batteries right now, at like that 10 to 15 cents per kilowatt hour, you can actually go off grid. The biggest downside there is that it's not sunny every day, right? So there will be a number of days per year where you're not able to generate enough electricity to even store in those batteries. If you are someone who insists on not having any fossil fuels, it's going to be expensive to provide twice the capacity to account for those 2 days. But if you're willing to have an off-grid generation that you only fire up for 2 or 3 days a year, you're going to save a massive amount of money, and you're going to be able to be entirely off-grid.
yeah. So because I think already, isn't it, for farmers, if you've got to go, I don't know, a kilometre or so, it's
100,000.
Yeah. No
Yeah.
sense in connecting yourself to the grid. You may as well be off grid.
Yep.
So look, Horizon Power right now in Western Australia in remote towns are pulling down their poles and wires to replace them with a solar battery with a diesel backup generator.
Yep.
Right.
Yep. That's
Okay.
telling.
It is. It's very indicative. And as that technology gets cheaper, the trend, so this is remote towns, all that's going to happen is that the economies of that system are going to become more and more available to people closer and closer to the cities.
Yeah, and that's one of my contentions from a global perspective is that you've got the some of the biggest areas that still need to be connected from electricity is India and Africa,
Yep.
and it just doesn't make sense to build a fully integrated grid anymore.
Exactly the same way as it didn't make sense to build a telecommunications network that was made out of copper. So I lived in West Africa for a couple of years. They basically jumped the whole copper step, right? They went straight to 3G, 4G. And why would you invest in all of that, especially in places where you've got geopolitical instability? It just makes an awful lot more sense to be able to get your energy/information independently of someone having to provide it for you and put it in the investment in the infrastructure to do so.
Yep. And so Solar City in the US is sort of one of the ones where it's one of Elon Musk's, I think, and one of their models is to try and put solar panels on people's houses to then sell the electricity back to the grid and to the homeowners themselves.
Yep.
I guess, what are your thoughts on that business model? So do you think, in 20 years' time, people will still own their own panels, or do you think we'll try the electricity companies will be trying to put panels on people's houses for free in order to sell electricity to them and their neighbours?
So I think it makes sense. It makes sense to get into that business even before it's economically feasible to do so. So Elon Musk is backing himself to put panels on other people's roofs and potentially then one day sell them batteries, knowing full well that technology trend is inexorable, and one day they will be making money out of selling that power generation and storage back to the customer, even if they're not making it today. So yes, I think that that trend will continue. Like I said, it doesn't commercially. I don't think it makes much sense today. But every indications are that if you're in the business and you've already got that contract with people, that it will make a lot more sense in years to come. And
Sorry,
think,
and it does seem that there are people out there already, mainly with businesses, I think, who are trying to use the batteries, who are trying to group together batteries using software to then put the power back out to the grid.
yep.
And then I guess that just seems like a scaling problem and a software problem to solve is like, how do I connect up 10,000 houses and take control of all their batteries at the same time and push the power back out to the grid when the need is there.
Yeah, look, you're in the business then of arbitraging along someone else's infrastructure, right? That's a tough business to be in, because if there's real money to be made there, the people who own the poles and wires are going to be the ones who end up taking a cut of it. So interesting. I think there's absolutely an opportunity there, but it's very easy for a utility company to come in and eat your lunch at some point.
Yeah, that's right. As they have with feed-in tariffs several times for solar.
Yeah,
It
of
seems
course. Yeah, encourage people to do it, and then take the cheese away.
taking it away. Exactly. And I mean, it does seem to me that from a if you were trying to design subsidies and things like that to actually help grow the solar industry, you would have thought you'd say, well, I'll start with a subsidy, and I will keep adding that subsidy. If I can't afford a higher one, I'll have a lower one and make sure it's steady and stable, so that people in the industry sort of can feel a sense of solidity. Whereas it does seem as if they've done exactly the opposite in most states, where they've added a big one, taken it off, added the big one, taken it off, and
with progressive and different governments. Yeah. So, and subsidies are a double-edged sword, right? And I think they can be quite punitive for the renewable energy. If you're in the business of doing something more efficiently, some subsidies can actually incentivize the wrong behavior. So if you genuinely want to push people away from fossil fuels, you actually want to encourage all the means for them to develop the technology rather than subsidize the outcome. Because ultimately, if you're subsidizing the outcome, you're not incentivizing people to do things more efficiently, which means you're not actually giving people or the technology and the companies a genuine chance to displace the incumbent. You're always going to be paying the price somewhere. There's no way of getting away. Energy follows the rules of thermodynamics, and no one's broken those in 13.8 billion years. So you can't. There's no free lunches when it comes to energy production. Subsidizing one can be at the detriment to the greater good.
Now, I know this is more of one, I guess, for the people at home, and I know Tim's interested. Just in terms of the mixing, for people who already have solar panels and looking at the new ones coming out and wanting to add more or less. I guess mixing old technology and new technology. What are your thoughts in terms of that?
I think the critical element is actually the inverters. It's less the solar panel. The solar panel is actually relatively simple. It's a photon comes and hits the silicon and pushes out an electron. That electron is the exact same electron that exists everywhere in the universe. So a solar panel, as long as it's the same voltage, doesn't know what the solar panel next to it looks like. What is the technology that does need to integrate is when you're regulating that voltage and inverting it into 240 volts at 50 hertz, which is what we run in Australia. Those systems need to be able to talk to each other in order to basically integrate power from one system with another system. And that's where the problems actually come in. It's not the solar panel per se, but the technology that does the voltage regulation and inversion.
Okay, changing tax quite a bit. So you spoke a little bit before about Chinese, getting most of the panels from China, and it seemed to be that, I guess it must be 10 years ago now, maybe even 15 years ago, where China made a concerted effort to subsidize and state back a lot of its companies and really drive down the price of solar panels to the stage where basically everywhere else in the world stopped making them.
Yep.
Is that still the case at the moment, or are we seeing solar manufacturers sort of pop up elsewhere?
Not that I know of. There's solar. There's people who claim to make solar panels are generally sticking together the silicon cells that are produced in these factories in China still. So it's just one element of the solar panel. So we do have solar panel manufacturers, but the actual core element, the silicon solar cell, is actually still coming from China. They did a fantastic job of making sure that no one was willing to compete with people in China. And yeah, I think that's still the case. It would be very difficult to compete with a solar panel manufacturer out of China today. And one of the reasons for that is there's still elements within the manufacturing of solar panel that actually take some manual labour. And if China has got the most competitive manual labour in the world, so it's very hard to compete there. I think we will only see a genuine competition for those sort of products when you've got a product that can be 100% produced autonomously by robots. When that day comes, then we can basically produce things cheaper than China.
And so if, I guess I'm just sort of extrapolating forward, just looking at risks and to the situation. So if the trade war got a lot worse and China started to, I guess, put some restrictions on it, and somebody did have to start up factories, I guess, say you wanted to build a solar panel factory in Australia sort of from scratch or in the US, how much more expensive do you think it would be than the current ones?
So I don't know if it would be any less or more expensive. It's really ultimately, if you look at the fundamentals that drive the cost of the factory, because the key thing, it's the labour that actually goes into the manufacturing of the panel. The key element in the real technology comes in producing the silicon billet. So that's a big chunk of silicon that you want to make as homogeneous as possible, as very few crystals within it, and then you slice it with a laser and as thin as possible to get the most out that you can. That's actually the technology. That's the most expensive part. That I believe you can transfer anywhere and I don't think China necessarily has a strategic advantage in producing those, or at least applying the technology.
From one of the things we've sort of been looking at from an investment perspective is it's hard to trying to find companies that are sort of will benefit from solar and batteries because the technology is often competing, and you never know who's going to come up with the latest and the greatest. And so one of the areas we've sort of found a little bit of investment success with in the past is finding the contractors who are effectively plugging these things into the networks or running the other, sort of doing the selling the shovels and picks, so to speak, to the miners.
Yeah, absolutely.
From your perspective, I guess, any of those that you find?
Look, you'd be really hard. You'd be really hard pushed to compete in the world of producing solar panels and batteries. Where there will be massive opportunity is actually in the applications that use those technologies. We've absolutely bet the house on the fact that construction going forward will have building integrated photovoltaics, and they'll have integrated battery systems. And if you're in the business of actually then selling the final product, and the what goes into it is effectively fungible because there's so many people doing it at lowest cost, that's where you have the opportunity, selling buildings that will be cheaper than other people's buildings because they've got this technology within them. Amazon recently, I think last year, bought a modular housing company, I think for $200 million. They recognised that getting into the actual structure itself was critical because they're pre-wiring Alexa into that building. If you own or control that part of the value chain, then you're able to control what the systems are that go into that. I think that's where the real dollars will be in the coming years.
Excellent.
Very good.
And then I guess just finally, from a government perspective, if you're talking to your local member or any of our listeners are talking to their local members, where are the regulations? Australia seems to have been quite anti-renewables in the past. And I guess the question is, if they would like to lobby people, or we would like to lobby for changes, what are the key areas do you think where the Australian government could step in and actually start helping?
Yeah, so gosh, this is a tough one, and I think there could be a whole podcast just dedicated to this very topic.
Yeah.
The My opinion, and as an engineer, there's a lot of regulations that actually make a lot of sense. There, a lot of things are there to protect current systems and protect people and things like that. It is quite onerous. You know, we live in a country where we have an extremely high quality of life because people look after us and put in place these regulations to protect consumers. They are absolutely onerous then for people to be able to work with. Renewables have struggled, and if you're a renewable, a solar farm, and you have to work with an existing grid, you have to work within the rules. But for mine, the real opportunity is where you can basically take out the transmission lines, right? If you can go off grid, then all of those regulations kind of become less of a concern. For all of our buildings, we're actually installing a low voltage DC bus. So this is like runs at 24 volts. So then all of a sudden you've got a electrical system that also can be wired up similar to the way you would wire up a caravan or a truck or a car. That then also reduces the risks, and then you are also then not subject to all of the same rules and regulations, which make it easier as well. There's a real perfect storm coming for that off-grid application of energy generation.
Okay, so does that mean if for people who are building new houses, and I think one of our chief strategists is actually just moving into his new house very shortly, so it's probably too late for him. So is that something they should be looking at then? Is it, sorry, the 24-volt bus? Was that what
yes, so look, it's not common at the moment. Our prototype, we installed 22 kVA cables in there, so this is really thick copper. The problem the problem with direct current, so solar panels generate at direct current and batteries store at direct current. All of our 240-volt system is alternating current, excellent for transmitting long distances, but you don't need it if you are generating where you're storing, where you're using it. It is definitely my sense that, and if you don't have to invert then DC into AC, you also save on the cost of that equipment and all those technical issues that we were talking about previously. So yeah, my money is definitely on the future of construction and housings. Housing will have low voltage DC buses. You'll invest in the cables because you need thicker cables when you're running high amps of direct current, but it will be a relatively insignificant cost because you're only distributing it within your house and out to the garage to charge your car and things like that. So yeah, we are definitely advocating with all of the buildings that we sell for all of our consumers, and anyone's got an application to maintain a 24-volt DC bus. If you need 240 volts, you basically put a small inverter next to the appliance or next to the application that you need to run at 240 volts.
Right.
Oh,
excellent.
Something to think about. Well, look, mindful of your time, David, and look, that's been a wonderful and amazing bit of insight, I think, into the big wide world of battery and also, of course, solar technology and how it's going to potentially, impact the future of Australian housing. Would you like to just take a couple of moments to let our listeners know how they can follow some of your work?
Oh gosh, yes. We've got the Iron Matrix website, ironmatrix.com. You can find out all about us there and contact us if you'd like to know more. I think this is one of the most exciting places to be working at the moment because this transition is going to make a massive difference, not just in Australia, but as you mentioned, Damien, all over the world where people are looking for lower cost access to energy. It's absolutely intensely exciting right now.
Really looking forward to seeing how it all works out. Thanks for coming along. We'd love to get you on board sometime soon.
Absolutely. I'd love to do it again.
Thanks very much. Thanks. David. So, Damien, terrific 50-odd minutes spent with David Morgan there. Got some incredible insights into the future of solar and batteries in Australia and Australian house building. What did you think?
Yeah, look, I've been writing on this topic for a number of years and just put out something just recently on this, just keeping up to speed with where the prices are going and how we really are. The prices keep coming down at such a rapid rate that we've reached this parity point far quicker than what I'd thought. And I think over the next few years, what you'll start to see is you really will see that the cost of solar plus a battery will start to displace the cost of just the fuel, because that's the issue. By building new facilities is definitely in a sunny place. It's all about renewables now. The issue is we've already spent the money to build the coal-fired power plants or the nuclear plants or the gas-fired plants. What I'm seeing in the costs is if they keep coming down at the rates they're coming at the moment, within 5 years, you'll be saying you can put on a new solar plus battery, which will actually displace the cost, just the fuel cost of running one of these gas-fired or coal-fired plants. And so at that stage, it becomes extremely disruptive for the existing players. So that was, I guess what he's saying and what I'm seeing from that is we're not there yet, and we might see that we start hitting some constraints and costs don't come down as quickly. But he's seeing what I'm seeing as well, which is heartening, that there aren't any obvious hurdles that's going to prevent us from getting there. And so that means a huge issue for anyone involved in some of these traditional technologies, depending upon where you are. But very much you do not want to be a high cost producer in any one of these fossil fuel or even other energy sources. You don't want to be a high cost producer because this solar plus batteries is just getting cheaper every year, and it's just going to push them off the out of the grid.
Yeah, and I thought it was quite clever as well, the way by choosing solar panels rather than weatherboards on the outside of your house, you get to run your air conditioner for free 24 hours a day as well.
Absolutely. Well, we might choose not to run it 24 hours a day, but yeah, having that extra power. And actually, we didn't mention it during the podcast, but it is important to say none of this is based on carbon prices. None of this is based on subsidies,
political tailwinds. Yeah.
Political tailwinds. They'll help us get there earlier, but the reality is this is purely just based on the economics, and that's where the whole idea of carbon prices and subsidies was bring that point forward. And the issue is that the technology's been moving so fast that point's been brought forward a hell of a lot quicker. And I'm still always hearing from people whenever I write these coming out and talking about, oh no, but you don't understand, we can't do it yet. They're the talking points from 5 years ago and 10 years ago. The issue is the costs have come down so rapidly that those talking points are no longer valid.
Very good. Well, that's it for now, and thanks for watching. If you like what you heard today and you'd like to hear more, head over to nucleuswealth.com/subscribe. Give us your email address, and in return we'll send you a weekly email with new webinar topics, links for our podcasts and other news from Nucleus Wealth. I certainly hope you've got something out of today, as I have, and we'll look forward to catching you with the next one. Cheers.